Hello everyone. So my name is Stephane Cerveau. I work at Igalia and I would like to present you the open source ecosystem of Vulkan Video. So that's why we name it like Vulkan Video is open. The Vulkan is definitely open source, the API, and so we are delighted like to provide like application who are able like to demonstrate Vulkan Video openly. So about me, I'm part of the multimedia team since 2022 when I joined Igalia. Started to work directly on Vulkan Video, and I worked on CTS with the TSG, and also I came with my background on GStreamer, so and to provide the support of Vulkan Video in GStreamer. So in this presentation, I'm gonna talk about. I'm gonna add more information than already done has done Srinath about Vulkan Video. I'm gonna talk about Mesa, GStreamer, FFmpeg, and Vulkan Video Sample, who are the three application, the four. Sorry, with Mesa, the four application open source using Vulkan Video. So what is Vulkan Video? Srinath already mentioned it, but it's a stateless codecs API. The idea is like this is very elementary. We don't keep any state in the driver, so that's the application who's keeping the state, and it provides the GPU hardware acceleration. It's using the video engine of the platform, and provide a unified API. It supports codecs such as H.264, H.265, AV1 right now, and also VP9 coming. The idea was to provide an API which would help to integrate video decoding and video encoding with the graphics and the displays to unify a bit this and save some overhead. The idea of also Vulkan Video is to be cross-platform, vendor neutral. There is only the capabilities of the implementation with telling that the difference of behavior from one implementation to another. So the timeline has been already exposed, but yeah, I'm gonna be quick on that. It's like March 2018, the TSG has been created and driven by HAVs such as AMD, Intel, and NVIDIA. We're creating the TSG. Provisional extension has been released in 2021, H.264, H.265 decode. And in February, so last year, after the Vulkanized 2024, we released the AV1 decode. And in November, last November, we released the AV1 encode and also the quantization map. So let's talk now about the application. That's the point of this presentation. So I'm gonna not be too much in Vulkan. I'm gonna be more over Vulkan right now. So let's talk first about Mesa. I guess you know all about Mesa, and so I'm gonna do a quick introduction on it. So it's a low-level graphics library. The idea is like there is like it began as an open source implementation of the Evangel, but it moved to Vulkan to implement the Vulkan specification on various GPUs. It supports a lot of these GPUs, Intel, AMD, NVIDIA, Raspberry Pi, and so on and so on. Contributors to Mesa are wide. There is like Igalia, of course, and AMD, Intel, Google, Collabora, Mesa community. So I encourage you to watch the last year presentation from my colleague about the 8 years of driver in Mesa in the last Vulkanized in 2024. The Vulkan Video history in Mesa. David Erlai started to work on AMD and Intel in 2022. There is a blog post about it. He started to experiment at the same time that the TSG was working on the specification. With Lean from FFmpeg, they provided the first implementation of like a decoder, H.264 decoder, and so like the driver part and application part, the FF part. Igalia joined with my colleague Victor Jacquet on the JStreamer side. We started to implement the decoder element in JStreamer. And Yu Junko, also from Igalia, started to work on Intel GPU in 2023. So levering the burden or the effort from David Erlai to work only on RADV and AMD GPU. So what is the Vulkan video status in 2025? So we support the encoders H.264, H.265 for both AMD and Intel implementation, RADV and NV. We implemented AV1 decode. AMD and RADV support AV1 decode. Only RADV support AV1 encode for now. AV1 encode and NV should come soon. We are also supporting video maintenance 1 now in Mesa. Video maintenance 2 is coming soon. I'm gonna speak about it later. So we both supporting AMD and Intel, and we having also the implementation coming. Recently in December, a nouveau driver, NVK driver has been released to support H.264, H.264, H.265 codecs in NVK. So that's a big step, and we're also having AV1 decoder under review. There is also a Zinc implementation, so it's an H.264 decoder based on Vulkan video inside under the curtain. It's a VAPI driver, and then you're using Vulkan video. It's a project from David Erlai, like a long-term project. So here is like a recap of the support. As you can see, we are supporting a lot of codecs now. So the challenges we have been facing implementing the drivers are the GPU hangs. Definitely there is not enough useful tool to investigate. Would be nice to implement more tool. RADV is, for example, hanging when we are giving a bad command, so we need to reboot the machine. It's kind of hard to implement. There is a lot of generation of GPUs. That the other challenge we have been facing to support all the common parameters, memory size, element. But I can tell you that the implementation is pretty good. It's working on a lot of hardware. The plans for 2025 in Mesa are the AV1 full support for both RADV and NV and NVK. Now that's NVK came in December. When I started this presentation, the NVK was not in my list. So yeah, it's pretty new and pretty exciting. And to support other GPUs, we would like to provide the Vulkan video to other GPUs. It would be nice. So now let's talk about the application, the third party, like the over the driver. We having the streamer, FFmpeg, and Vulkan video samples. So let's talk first about JStreamer. So I don't know if you know about JStreamer, but I'm gonna give you like a quick introduction about it. It's a 25 years old framework, so it's a very stable framework about streaming media application. It supports a lot of backend from DX12 to small library. To the idea of JStreamer is to be like a layer over existing libraries. So it provides like an interconnection system. I'm gonna show you in this slide like the interconnection system, and it helps to interconnect element for the source, the transform, and the sink. So the idea is like the source can be like a streaming source, a transform can be a decoder, and the sink could be like a display. It's native multi-platform. It's working on all the system and highly optimized. It's written in Rust and in C. So here is like a pipeline, the common name for the GStreamer interconnected system. So as you can see on screen, it's a bit small, but yeah. The video test SRC is this pattern, and then we go through a Vulkan upload to map to the Vulkan memory manager, and then we create like an encoder. We decode with the Vulkan. We download the image and we provide it to the sink. The sink in this case it's X window. So the Vulkan video support is pretty good. We both support decode and encode in H.264, H.265. We support AV1. Well, we are currently trying to support AV1. We're having like an element under review, but we're still having some issues. The AV1 encode is only a unit test for now. It's the element is not ready. Now I'm gonna demonstrate you the result with Fluster. So Fluster, what is Fluster? It's a framework to validate the decoders upon like a list of media about test vectors. So it's a Python-based framework, and it provides a lot of test vectors to validate the decoders. So here, what I did is like I ran it on NVIDIA, RADV, and NV on Linux, and I compare it to VAPI with the GStreamer. So the result is definitely better for VAPI because it's an older implementation with a lot of background. The result for the other for Vulkan is pretty good. We are having good progress. As you can see, we are more than 70% above 80% above the result. So there is also the Windows result. You can see the complete result in a spreadsheet on a Google Drive and see the evolution of the support. And you can see that the result is pretty similar to the Linux one. So that's the idea of Vulkan Video, like to be cross-platform and easy to integrate. Challenges we have been facing in GStreamer are the different behavior from hardware vendor and the vendor caps. For example, the TPP is not managed the same within a version of NVIDIA driver or within vendor. Not drivers but hardwares. And also from AMD to Intel, it's not the same way to handle the DPB, for example. So that's something we had to handle inside the code. We had like some hardware crashes, thanks to the validation layer, were really complete and really helpful when you are catching, when you're trying to catch a problem. But as Srinath mentioned, we don't catch all the problem with validation layer, and the codec parameters is one of the problem we are not catching right now. So it's creating some crashes, and we are discussing and thinking about how we could manage this in a better way for an application writer. So what's next? In GStreamer, we planning to have the H.264 encoders review and merge. This should happen in the coming months. I don't know if it's going to be in the 1.26 release, but it could happen. It's not impossible, but, because 1.26 it should happen like in a month. We hope to have everyone codec review and merge soon. Also, the video maintenance too support, and VP9. Since that the extension is coming, we plan to have it in 2025 also. So now let's talk about FFmpeg. I guess I don't know who knows about the streamer here. Yeah, and FFmpeg. Yeah, a bit more. Definitely a framework more well known for video decoding. So definitely, this is not, I mean, a rival, but it's definitely they are working along with GStreamer. GStreamer is using FFmpeg inside, for example, for video code decoding. It's also a 20 years old multimedia framework. It's more a library. You calling some methods, you can demux, you can decode contents with the library. It's also native multi-platform, low level, very low level, including assembly code to optimize the decoding or encoding part. And yeah, it's a very amazing project also. It supports basically everything in Vulkan video except the AV1 encode. It should happen soon. I'm sure that there is a branch somewhere about AV1 encode. The Linux cluster results are also a bit better than GStreamer, maybe because of the history of FFmpeg. FFmpeg has been on the working actively on Vulkan videos for a longer while than GStreamer. But yeah, there is like still room of improvement. You can see that the difference with Windows is there is no difference. It's like really homogeneous. So what's next? The AV1 encode. We hope we're gonna have it in a future release, and the video maintenance to support, as we would need the inline parameters like for the codec parameters. I'm gonna add another part on Vulkan video sample because Sunil had already mentioned it, but I have to say that now it's part of the Khronos Group, since that it has been released by generously by NVIDIA to the Khronos Group, so you can provide your own merge request, your own you can contribute to it. It's an official CLI application. It decode and encode contents, but there is also a library you can use to encode. Right now, we are working on a decode library. It's the main implementation for video extension released. Usually, NVIDIA is providing like support for the extension along with the Vulkan video samples. It's native multi-platform also. It works on Linux and Windows. In comparison with the other framework, it definitely supports everything. H.264, H.265, AV1. VP9 should come soon. It's already in the pipeline. I didn't mention this line in my previous slide, but you can have like a Vulkan video status updates within this page, where you can have like all the latest updates, the blogs, conference that can help you to understand a bit better Vulkan video. The Fluster result, so there is like zero. That's a pity because we just have a bug with Mesa, but it should be fixed soon. But otherwise, the results are really good, as good as a FFmpeg one. So what's next for Vulkan video samples? It's a first release. We would like to release the first version used in your applications. It would help, like, if you want to use directly Vulkan video sample and not implement the Vulkan video extensions use. And the decode library should come in 2025. As I said, like the encoder library is already available and it's used by the CTS internally for AV1 encode test. So it's already mature. That's why we would need also 1.0 version, like to say that we are using this version for the CTS, because CTS is now gonna rely on Vulkan video samples. Video maintenance to support should happen soon, I assume. And the better support of the meta driver, that would be nice, like to complete the offering. And VP9 coming this year. So that's all for me.